In this video, we're going to be going over the formation of stalactites, and this is our part 1 video inside of chemistry, chapter 2. And we're also going to talk about common names versus systematic chemical names. So let's get started with this video. So just before we start, we're going to go over a quick overview of what we're going to do in chapter 2. So chapter 2 contains the following information. So number 1 is how to name and write formulas for ionic and molecular compounds in a way that reflects their composition. Number 2, we have how theories of bonding in ionic and molecular compounds can help explain their physical properties. And for number 3, we have properties of acids and bases along with necessary precautions for safe handling. So these are just some of the things that we're going to cover inside of chapter 2. So now let's get started with this part 1 video, and we're going to start off with the formation of stalactites. So the formation of stalactites involves several steps, and we're going to talk about this because it has a lot of things that can relate to chemistry. So on the right we have a picture of the different formations and steps, and we're just going to read, and then we can also use this picture to help visualize all the things that we're saying. So for step number 1, we have the formation of limestone layers. So over millions of years, the shells of dead sea creatures primarily composed of calcium carbonate, which is CaCO3, accumulates, and then it forms a limestone seabed. So if we look at this picture here, on the top, the first image, so on this hill you can see all of this is limestone, and this is accumulated when over millions of years, when all these dead sea creatures die. This is all of their bones and shells, which is calcium carbonate, which is CaCO3. So for step number 1, we have the formation of limestone layers. For step number 2, we have geological movement. So movement within the Earth's crust lifts the limestone layers above sea level, which eventually results in this layer being positioned deep below the surface of the land. So for step number 2, we can see that the movement of the Earth's crust also has an impact because it lifts the limestone layer above the sea level. So we can see that this limestone layer is high above compared to the seawater. So this is the first and second step of the formation of stalactites. For step number 3, we have the formation of carbonic acid. And so as rain falls throughout the atmosphere, it absorbs carbon dioxide, which is CO2, and it absorbs that from the air. And then once those two combine together, it forms carbonic acid or carbonic acid, which is H2CO3. So for step number 3, just as a quick summary, since rain also falls, rain has a type of acid inside of it. So once it combines with the carbon dioxide from the air, so then it forms a new carbonic acid, which is H2CO3. And for step number 4, we have this acid that seeps into the soil. So the carbonic acid then seeps into the soil, which reach the limestone layers. For step number 5, we have the dissolution of limestone. So this is where the carbonic acid slowly dissolves the calcium carbonate in the limestone, washing it away. So as we can see here in this step, in this picture, we can see that it goes through the soil and slowly it takes out all the limestone over there and washes it away inside of the water. For step number 6, we have the formation of caverns. So the continuous dissolution of limestone by the acid leads to the formation of large caverns. So these caverns look like this. As we can see, there's many different examples. It looks like a huge cave, as it says in the name. And for step number 7, we have the reversal process, which is also the formation of stalactites. So as a part of the reversal process, some small drops of calcium carbonate cling to the cave's ceiling. So as we can see here, that for step number 7, which is the reversal process, or otherwise known as the formation of stalactites, so small drops of these calcium carbonates cling to the ceiling, and that's how we actually get these stalactites. So stalactites are these ice crystals that you can kind of say, so that cling to the ceiling of the caves. So this is the formation of stalactites, and we covered over 7 different steps. So these give a little bit of a quick introduction to this chapter part 2. So now we're going to go over the difference between common and systematic chemical names. So we're going to take 3 different examples so that we can understand the difference between these two. And for the first example, we have sodium hydrogen carbonate, which is NaHCO3. So this is commonly known as baking soda, and sodium hydrogen carbonate is a white solid that is crystalline but often appears as a fine powder. So sodium hydrogen carbonate is commonly known as baking soda, and we know what baking soda is. It's like white solid that looks like crystals, but it's actually powder, as we can see in this picture. And the common name for this is baking soda, as we said, and the chemical name for baking soda is NaHCO3. So the common name basically means typically what everyone says. So nobody in the common world is going to say NaHCO3. Instead, they're going to say baking soda. But instead, if we were doing an experiment, in a science experiment, and instead of using baking soda, we might use NaHCO3, which is the same thing, but it's just the difference between the chemical and the common name. So now we're going to go over the second example, which is calcium carbonate, which is also known as CaCO3. So calcium carbonate is also known as chalk in its natural form. So calcium carbonate is also a common substance that is found in rocks. So as we explained before in the stalactites, so we know that calcium carbonate is CaCO3, and in its natural form it's chalk, and it's also found in many different things as well. So the common name for calcium carbonate, or CaCO3, is chalk, and for the chemical name we have CaCO3. So this is our second example to help us understand about chemical and systematic names. And for our final example, we have solid carbon dioxide, which is CO2 in solid form. So solid carbon dioxide is referred to as dry ice in a solid state, and solid carbon dioxide is primarily used as a cooling agent. So basically solid carbon dioxide is dry ice. So the common name is dry ice, and the chemical name is CO2 in solid form. So these were the three different examples that we used to help us understand about the common and chemical names. So now hopefully we have a good understanding about the differences between both of these things. Now we're going to go over a summary for this video. So we discussed the difference between common names and systematic names with some examples. We talked about a limestone caves formation to illustrate the real application of chemistry. And for our upcoming content, for our next part 2 video, we're going to talk about binary compounds. So that summarizes everything for this video, so thank you so much for watching from Try to Be Useful, and we'll see you guys in our next video.